Hello everyone, welcome to the next exercise that we're looking at, which is similar figures. So by the end of this lesson, we will hopefully be able to use scale factors and ratios to compare and draw different shapes, and you can prove if shapes are similar or not. So looking at scale factors and similar figures, a scale is basically a ratio that's going to be used to compare two figures together. Okay, so two figures that are of a similar shape. So we say that two figures are similar, okay, if they are the same shape, but one is a direct enlargement of the other. Okay, so they're both the same shape, but one's just larger in scale than the other. So for example, a scale factor of 1 to 10 measures that one shape is 10 times bigger than the first shape. Okay, so if we look here, we've got 3 centimeters by 4 centimeters, and we've got 30 centimeters by 40 centimeters. So that has increased by a scale factor of 10. Okay, so a scale factor basically measures how much something needs to be enlarged or reduced to produce a similar figure. Okay, so it can be a whole number, or it can be a proper fraction or an improper fraction. So looking at how we actually find what the scale factor is or what the ratio is that we're going to be looking at, okay, we can usually write it as a ratio or as a fraction. So in order to calculate a scale factor, what we do is we take whatever the length is of the second figure and we divide it by that corresponding length of the first figure. So if we're looking at this vertical line, we're also looking at the vertical of the other shape. Okay, so in terms of this, we do the length of the second one. Okay, so if we're doing the orange, we do the length of 30, divide it by length of 3, which equals 10. Okay, or we can do the green one, which is 40 over 4. So 40 over 4 is also 10. Okay, so the ratio that we're using is going to be 1 to 10 for this one. Okay, this is 1 to 10 for this one. That means this shape here, this second one, is 10 times larger than this smaller shape here. In terms of looking at polygons and similarity, okay, polygons are basically similar if they fulfill these 2 dot points. So a polygon is basically any shape that has 3 or more sides, okay? So their corresponding angles have to be equal, okay? So if we look at this shape here, angle B, okay, and angle P have to be the same angle, okay? Corresponding sides also have to be in the same ratio. So this one and this one have to be in a ratio of each other. If we look at these 2 polygons here, okay, the bottom 2, they are also similar, it's just rotated. So if we were to flip this way, okay, we would end up with 2 polygons that are also similar. So it doesn't matter if they're rotated, as long as we can match up the angles and the sides as being in the same ratio, then we say that they are similar, even if they're rotated. So what we could be asked to do is be given 2 shapes, okay, and be asked to identify what the scale factor is. So looking at this, okay, we would say that this line would be corresponding to this line. So in order to find the scale factor, if this is shape number 1 and this is shape number 2, we would take that 11.9 and divide it by the corresponding side, which is 3.4. So 11.9 divided by 3.4 equals 3.5, which is equivalent to 7 over 2. Okay, so that's our scale factor. We could then be asked to figure out an unknown, which is x. So in this instance, this corresponding side and this corresponding side correspond to each other, okay? But we don't have a value for x, which is why in our scale factor we use the left-hand side line. So if polygons are similar, basically the scale factors should also line up. So we can use this to find the value of x. So what we do is we take what our scale factor is, which was 7/2. Okay, so we're going to take that scale factor, 7/2, and we're going to say that that's equal to x over 1.6. Okay, because that's my scale factor now. We're finding our unknown over what its corresponding is. We can use cross multiplication, so 2x equals 7 times 1.6, or we could have just put this into our solve. Okay, so solve bracket, comma, x bracket, and you'll end up with x equals 5.6. So we've been able to determine that this length here would be 5.6. All right, in terms of looking at triangles and similarity, okay, this is basically a method for solving similar triangles. So what you have to do is step 1, identify the corresponding sides, okay, by looking at the different angles, okay, that are associated. We need to then write a ratio question for the corresponding sides. Okay, so we write each side over each side. So side 1 goes over side 1, side 2 goes over side 2. This formula is the important one that we're going to be looking at. And then we can solve for the unknown value. So it doesn't matter whether triangle 1 or 2 lengths appear as the numerator, okay, as long as it's the same on both sides. So as long as you do both triangle 1s on the top and both triangle 2s at the bottom, it doesn't matter which side you put it on. So if we were to look at an example question here, okay, we have triangle 1 and we have triangle 2, okay, we can see that this shaded angle matches up with this shaded angle and this dotted angle matches up with this dotted angle, okay, which would mean that this side length between both the angles corresponds to this side length between both of my angles, okay. I like to highlight things in my answers to make sure I know that I'm using the correct working. So what we would do is we would say, okay, this 9 corresponds to this y, this 8 corresponds to this 12. So the way that you would write your ratio is you would go 9 over y equals 8 over 12. Okay, that's meant to be an equal sign there. Using your solve function, okay, you could end up with solving that to be y equals 13.5. So we've been able to calculate the unknown. In terms of questions, guys, you guys are going to be doing 10.6, exam prep 1, 2, 3, and exam practice questions. Another just quick example of something that you could get that's related to this sort of stuff is a triangle that has a triangle inside. So we have our small triangle and we have our big triangle. And that's the same way you could be told that this is D, this is 14, this side length is 12, this side length is 24, and you know that this angle matches up with this angle, and this angle matches up with this angle. So your small and big triangle are actually similar to each other. Okay, so if I drew my small triangle and I drew my big triangle, the lengths that I would end up with is this would be 14 and this would be 24, okay, to show this upper triangle. And then I'd show my big triangle, which would be D, and then 12 plus 24, which is 36. And I'd use the same working out. Okay, so I'd do triangle 1 over corresponding triangle 2, which is D, and then triangle 1, 24 over corresponding, which is 36, and then use my solve function again. Okay, so just in your calculator, you do solve 14 divided by D equals 24 divided by 36, comma D, and it would give you your answer, which in this case would be D equals 21. Try it on your calculator, see if it works. If you have any questions, leave them in the comments below. Have a good day. Bye.